Hello everybody and welcome back to another C++ programming exercise video, and today we're going to be doing programming exercise number 6. Now programming exercise number 6 says, write a program that uses a random number generator to generate a 2-digit positive number and allows the user to perform one or more of the following operations. A. Double the number. B. Reverse the digits of the number. C. Raise the digits of the number to the power 2, 3, or 4. D. Sum the digits of the number. E. If the number is a 2-digit number, then raise the first digit to the power of the second number. And F. If the number is a 3-digit number and the last digit is less than or equal to 4, then raise the first 2 digits to the power of the last digit. Also, after performing an operation, if the number is less than 10, add 10 to the number. Also, after each operation, determine if the number is prime. Each successive operation should be performed on the number generated by the last operation. Your program should not contain any global variables, and each of these operations must be implemented by a separate function. Also, your program should be menu-driven. Now, the first thing to do is include all of these header files. Now, these won't all come included for you, but I'm just including a couple that you can see. Now, you see here that we have hashtag. You need to include IOStream. You need to include these two because they allow you to generate random numbers, and you need to include this one because it gives you a couple of new functions that you can use and make math a bit easier for C++. Now, first you need to add in a couple of predefined functions. Not predefined functions. You need to add in a couple of function prototypes. First, you need to add in int double num bool is num prime, int reverse digit, int sum digits, int raised to the power 2, 3, or 4, raise first digit to the power of the second digit, raise the first digit and second digit to the power of the third digit, add 10, and void menu. Now, the first thing we need to do is declare two variables, num and choice. The next thing we need to do is we need to do srand time 0. Now, you may be wondering a bit what in the world this means. Now, what this means is it actually changes the seed in a way so that, actually, let me take a step back. Okay? Using the srand function on its own without using the time 0, using the srand on its own sets the seed of the random generator algorithm used by the function random. Now, the seed pretty much changes how the algorithm works. Now, let's say I used a seed of 1 that would give me a completely different result as if I had used a seed of 5. Now, the reason that we use seeds is because randomly generated numbers in the computer aren't exactly random. A computer uses an algorithm to determine a random number, but nothing is truly random. Now, using the srand with the time inside of it makes use of the clock inside of the computer that you are using to make truly randomized numbers. This means that the seed is different literally every single second or millisecond. Yeah. So that means you get a truly random number, which is very useful, especially in these sort of applications. Now, once we are done with that, we can write in and declare a random number. Now, this random number is going to be num. And now, since num cannot be less than 10, num must be equal to random percentage sign 10. So pretty much we just need to keep on doing it until we get a number greater than 10. Now keep in mind, this pretty much generates a number from 0 to 100. Now, once we are done with this, we can move on and write in cout the 2-digit number is, because we actually want a 2-digit number that is not less than 10. And now after we write in that, we display our menu. And then we take in the choice. Cout and down. And now, while choice is not equal to 9, we switch choice and now we write in case 1 and now num is equal to double num. And let me plug in num right there. And then we cout num is not prime. And then we write in num is equal to add 10 num. And then we can break. Now we can actually start off and make this a bit faster for ourselves by writing in case 2 case 3 case for case 5, case 6, default, oh, and pretty much for the default, it's always going to be invalid choice. And now right there, the program should end, actually right here. The switch loop should end. Now just take a look at what that has. And now make sure that you have curly brackets right like that. I accidentally forgot to put those in. Put them in right there. Now we have this. And now, hold on, I'm just gonna fix this indentation. There we go. I just move that there. And then there we have it. That's all good. And now outside of the switch statement, right here, we need to have menu, CIN, choice, cout, and out. So right now we sort of just did all this. And now something that you can also do is that for each of these, at the end, we have this right there. We always have something that looks a bit like this. And we have this. We always have to add 10. Now inside of the add 10, there's going to be a if statement or a switch statement, whichever, which determines whether the number has to be added to 10 or not. So you can just go ahead and copy and paste the break inside of every single thing. Oop, accidentally zoomed out there. There we go. We have 10 added to each and every single one of those. And there we go. Now we can get to doing the operations in here. Now for the most part, we have the while loops done in here. All we need to do is finish it off by making we already have the main function done here. All we need to do is finish what's inside these cases. So we need to write in num, which is equal to reverse digit num And now if is num prime num, then we can see out num is prime else and also don't forget to write in the end else at the end. And that's the end for the second case. Right here, we have the third case, which is num is equal to raise POW 2, 3, 4, and right in here we have to do num. And now if is num prime, and you write in num right there, we can see out oh wait, sorry, this isn't the oh yeah, and there we go. Thought I made a typo for a second, guys, sorry. We can see out num is prime else we can see out num is not prime. Oh, and I actually just realized we're actually going to have this is also going to be in every single one of these because we have to inform the user whether their number is prime or not. So make sure you copy and paste what's in here. Oh, and don't put that there. And there we go. Now for number 3, we already have the function written down. Here we need to add the function for case 4. We need to write in num is equal to raise power. Oh, sorry. This is actually going to be num is equal to sum of the digits. And we plug num in. After that, we can, in case 5, we can write in num is equal to raised first digit second digit. And then we plug in num where it needs to be plugged in. And then right here, just write in num is equal to raise first digit, second digit, power third digit. And we write in num right there. And right there we have the end of the main function. And now we get to define the functions that we need to define. First we define double num. First we write in return 2 times num then we write in bool is num prime, and then we use int num. We enter, write in parentheses, and we can write in int square root num, int divisor, and now if num is equal to 2, we return true. Else if num percentage sign 2 is equal to 0, then we return false. Else we can write in square root num is equal to static cast integer square root static cast double num. And now while divisor is less than or equal to square root num, if num percentage sign divisor is equal to 0, we can return false. Else divisor is equal to divisor plus 2. And after that, we return true. Now I think about right here is a good time to step back and take a look at what we just wrote. Now if you take a look, double num is pretty simple. You just double the number. And for is num is prime, you may know that if the square root of a number, this is supposed to be equal to 3. Okay, so basically what we have here is that we take the square root. We have the square root of num converted to a double, and then we have the square root, and then we have the square. Okay, so we have the square root of num converted to a double, converted into an integer. So that pretty much means that we get the square root of num and turn it into an integer, basically. Pretty simple, right? Now on to the next part, we go where until divisor, so divisor currently is actually equal to 3. Now while divisor is less than or equal to the square root of the number, then we have if num %divisor is equal to 0, meaning num divided by the divisor gives you a whole number, then it returns false, meaning that it is not a prime number. But if that does not return true and num divided by the divisor does not return a whole number, then you just add 2 to the divisor, and it keeps on going on until the divisor is greater than the square root of the number. And then if that happens, then we return true, which is fairly simple. Now that was a pretty simple function, really. And none of the other functions are very difficult from here on out. They may be a bit long, but by no means are they hard to understand. Now, the first thing we need to do right after this is we need to enter, and then we need to write in the function prototype for reverse digit. Now you see here you need to write in this, and then after you write in that, you can already get to declaring a couple of variables inside. First you need to write in int reverse num, which is going to be equal to 0, and then you need to write in bool is negative, which is equal to 0. Which is equal to false currently. And now, if num is less than 0, then you write in some parentheses and write in num is equal to negative num, semicolon, and now is negative is equal to true. And now while num is greater than 0, then you can enter and write in reverse num is equal to reverse num times 10 plus num percentage sign 10. Now this keeps on going until num is less than 0 or equal to 0, whichever comes first. And there we go. And now, if is negative, can write in reverse num is equal to negative reverse num. And then we can return reverse num. Now I'm just gonna take a little bit of time to explain to you how this reverse digit works. First, we need to find out if this number is negative. If it is negative, if it is less than 0, which means it's negative, then we multiply the number by -1, or you just make num equal to negative version of num, which makes it positive, and you turn is negative to true. This will become useful when you check if it is negative later on. So now while num is greater than 0, in this case, then the reverse num is equal to reverse num times 10 plus times num percentage modulo 10. And then num is getting divided by 10. So each time reverse num gets multiplied by 10, it goes up a space in the place value, and then num's digit gets added into its ones digit. So then if is negative is equal to true, then reverse num just gets changed into the negative version of reverse num, and then we just return reverse num. And now we are pretty much done with that function. Now we can write in int sum digits. Now sum digits is equal to int num. Now we can write in int sum is equal to 0. And now while num is greater than 0, then we make sum is equal to sum plus num percentage sign 10, and now num is equal to num divided by 10. And then after that we return sum. And now you can see that we have all of this. Now this follows very closely related to the reverse digit, except in this time it's a little bit more simpler. It doesn't really matter about the negative sign in this case, but now you can see here that pretty much each time the ones digit gets added to the sum, and then the ones digit gets removed from num. And that keeps on going until num is less than or equal to 0. And then after that, we can go on and declare the next. We can go on and declare the next one. So right here, we come and we have int exponent and then we can see out enter power 2, 3, 4. And then after that, we cin exponent, and then we see out endo. Now, once we are done with that, we can go on and get into the calculations. Now, if 2 is less than or equal to exponent and exponent is less than or equal to 4, then we return static cast and POW num times 1.0 comma exponent. Else we can see out only power 2, 3, 4 is allowed. Period. Endo. And then we can return num. Now I'm gonna sort of explain to you how this works. Now first up, the user enters the power 2, 3, and 4. And then from there, if that is between 2, 3, and now if the power entered is 2, 3, or 4, then we convert num. Then we convert num to a double by multiplying it by 1.0, and then we raise it to the power of exponent, and then we convert that whole thing into an integer by using the static cast, and then we return it. And then else, if that is not true, then we just write in only the power 2, 3, and 4 is allowed, and we return the number back where it came from. Now that we are done with the raise power 2, 3, or 4, and then we could move on and come here and write in int raise power, raise first digit to the power of second digit. And then we write in int num right there. Now the first thing that we need to do is we need to come right here and write in if 10 is less than or equal to num and num is less than 100, then you can enter and you can write in int first is equal to num over 10 and int second is equal to num percentage sign 10. And then we can return static cast int POW first times 1.0 comma second. And we can come here and else we can CL to perform this operation your number must have only 2 digits. And no. And then we return num. Now let's take a step back and take a look at what this says. Now we can see here that if 10 is less than or equal to num and num is less than 10, and num is less than 100, that means that num is a 2-digit number and we can do our stuff peacefully. So the first thing we need to do is get the first digit. Now in this case the first digit will be num divided by 10. The second digit will be num percentage sign 10. And now we just raise the first digit to the second digit's power. And then we convert that into an int just to be safe. And we can move on. Oh, wait, sorry. Have a couple of semicolons to add. Also, don't be afraid. If you run this problem, you may get a lot of errors, but that's just because it's a fairly long problem. Anyways, we could get going. Here we have raise first and second power at the third digit. So here I'm going to add in this, enter, and write in some parentheses. And now if this is a 3-digit number and it is less than or equal to num and the num is less than 1000, then we can write in int x is equal to num over 10. Int y is equal to num percentage sign 10. Then right here, we can write in if 0 is less than or equal to y, and y is less than or equal to 4, then we can return static cast int POW x times 1.0 comma y. Else and then CL the last digit must be less than or equal to 4. And then here we can endo. And then we return the num finally. And then we can write in else. We can see out to perform this operation, comma, it must be a 3-digit number. Endo. And we return num. Now we're gonna take a look at what this function does, like we always do, and we have done for each of these functions. First up, we first get the, now you can see here, we enter a digit, and y in this case is the ones digit, and x is the other 2 digit, pretty much the hundreds place and the tens place. Now what we do is that if y is between 0 and 4, then we raise x to the power of y. If y is not between 0 and 4, then we just return num, and if it is not a 3-digit number, then we return num as it is. After that, we can now go on and define the add 10 function. And now if num is less than 10, then we come here and we can see out num is less than 10, comma, so adding 10 to it. And now num is equal to num plus 10. And then we can return num. So this pretty much just adds 10 to num if num is less than 10. Pretty simple as well. Now we can write in here void menu. Now this is a void function. We do not have to put anything inside the brackets. And here, all we need to do is cout 1, enter 1, 2, double the number, period, and L, cout 2, enter 2 to reverse the digits of the number, period, endo, and cout 3. Enter 3 to raise the number to the power of 2, 3, or 4. And then we can cout 4, enter 4 to sum the digits of the number. And L. And now we can cout 5, enter 5 to raise the first digit to the power of the second digit. Endo, and then we can cout 9. I mean, actually cout 6. 6. Enter 6 to raise the first 2 digits of to the power of the last digit. Then we can cout 9, enter 9 to terminate the program. And let me just add periods to all of these. And there we go. That's actually the end of the program. Now I think it is safe to run it. Now, of course, there's going to be a couple of, errors. I'm going to go and fix them. Let me check out what's here. I accidentally forgot to write in the parentheses for the random. Okay, now I think that should be it. And there we go. So now I could enter 1 to double that number. 158 is not prime. Nice. I can enter 2 to get 188.51. 3, 2. 4. 5. Okay. 6. 'Okay. Enter 3 and raise it to the power of 2. Just 121 and enter 6. 12 is not prime. And I can enter 9 to terminate the program, and we are done. Now I hope you all had a great time doing this programming exercise along with me. I hope you guys can have a fun time solving this program on yourselves, although I have to agree this was very long. I don't even know how long this video is is right now, but it is quite long. But I guess you could say that, wow, that's 235 lines of code. But that was a pretty good program nonetheless. Now I hope you guys had a great time, and I will see you in the next video. Bye!